Hi, good afternoon, one and all. You're very welcome to today's webinar where we'll be showcasing the new features you have to look forward to in MasterSeries 2019. So we're going to take a quick run through what we've been working on for you in the MasterSeries 2019 version, which is due to be imminently released. We'll talk a bit more about that in a few moments. The primary features we're looking at here today are some redesign of the MasterSeries front screen and the file selection menus, just making it a lot easier to access your modules from the get-go. So a new design, instead of the menu systems along the top, a much more rationalized and easier to navigate set of icons indicating the main modules and where they can be accessed. Likewise, the use of the file selector has been very much modernized and rationalized and is much easier to use with nice new preview features. We'll see some of those in a second or two as well. A couple of things to note are actually there's been some rationalization in terms of some of what we felt were the more redundant features from modules which are accessible, and namely the access of the MasterKey steel design as a standalone module. We felt was something that we had no longer wish to continue in terms of providing that, because really the power of the MasterKey steel design is when it's integrated with MasterFrame, and that's really where you'll access that exclusively from here on in. So let's get going. Next up, we're looking at MasterKey connections. Quite a bit done on MasterKey connections for this version. A lovely new editing facility whereby we've got much more graphical interaction with the graphics of the connection, so you can click on items, columns, beams, plates, dimensions, and that navigates to you the related input of that item, making it much easier to find in the editing interface where the actual graphical component can be controlled. I think you'll find that will speed up the editing quite significantly. The MasterKey Simple Connections module, as you know, for those of you who maybe are not familiar, the MasterKey Connections is split into MasterKey Simple Connections and MasterKey Moment Connection modules. The MasterKey Simple Connections sees 4 new types of bracing connection design for this version. Got some little screenshots there of some of the different configurations covering the 4 main types and a variation of one of the types as well in the last little icon there. And so we've got, we're going to take a look at those where we've got vertical bracing to a major column, vertical bracing to a major beam, and vertical bracing to a base plate. Here we've got actually horizontal bracing to the minor axis of a beam. And finally, we've got some vertical bracing to a beam, which is actually an angle, so it's a fully bolted connection in this scenario. The MasterKey Moment connections as well see some new improvements. We've got a new connection for a column to beam. Instead of a beam to column, it's a column to beam, whereby the beam is the major component that the column is then connected to. So that presents a new style of connection there in the Moment Connection module. A couple of new features as well, which are really useful for the moment connections, for beam to column moment connections and also beam to beam moment connections, is the handling of quite a common scenario which arose whereby the connection was in full compression or full tension, which is slightly outside the scope of the design methodologies presented in the green books for these connections, and that's now fully handled by the software. Moving away from connections, we've got a host of new facilities in the MasterFrame Pro line, patch and point loading, a completely new interface for the creation of these types of loading, much more graphical, much more flexible, and adding lots of new functionality also. So you've got the things like varying line and patch loads, and also patch loads can be any shapes, but much more than that. It's a lot faster, a lot more graphical, and a lot more powerful editing interfaces there to control those types of loadings. A little screenshot there of some of the interface that we're going to take a detailed look at in just a moment or two. Also new in MasterSeries 2019 is the MasterKey PileCap integration with MasterFrame. So we've had the MasterKey PileCap design for a while. Actually, earlier on in 2018 saw a significant upgrade of the MasterKey PileCap to include the handling of moments and column offset eccentricities. So there's quite a bit of new facility introduced for the pile cap design about this time last year, and that then subsequently has allowed us to go full on with the integration with MasterFrame, as it handles all of the axial force, the moments and everything coming from the columns. Just a note as well, the MasterKey masonry design saw some new features which actually were released to you guys back at the beginning of February. These features do come under the umbrella of the MasterSeries 2019 release because they're only available as 2019 maintained customers. So those are part of your 2019 feature set, if you like. One of the feature sets that we did talk about in the MasterKey masonry design was the proprietary wind post manufacturing, and that's actually something that has been held off for this imminent release, but it will come later on in the year. That's something that's currently actively under development. A new feature that we've been talking about for quite some time and is a significant one that's still in the pipeline is the introduction of a more detailed and dedicated slab design and punching shear designed facility for slabs in the MasterSeries. So obviously, for you guys that are familiar, we've had the MasterKey finite element module, which has had the ability to analyze and do some pseudo design on slabs up to this point, but there's much more facilities coming there on that. The development of which is well advanced, and I'm just showing you some screenshots here to show you that there's definitely something coming in the pipeline for this. So we had a screenshot there of some peak moment or peak design over a column head with interface for specifying the amount of reinforcement, and a lot of thought has gone into how the workflow in this is presented in terms of basic bars plus additional auto design bars, or whether you want to do auto design at all, and all of which then obviously leads into a punching shear design, and it's a really nice looking, like shaping up to be a really nice interface and feature set for MasterFrame flat slab design. This is earmarked for release in an autumn version, and we'll keep you posted on the progress on that. But things are going extremely well with that, but not unfortunately making the cut for this MasterSeries 2019 release in a few weeks' time. Okay, when it's available, we're aiming for full release around the end of April, start of May. Beta version testing program begins in just 2 weeks' time. So if you're interested in participating in that, you can, of course, notify or let us know of your interest after the webinar, and we'll, of course, be happy to furnish you with a beta copy once that program begins in, which should be about 2 weeks' time. Okay, let's get stuck into MasterSeries then, and let's show you some of these things in the flesh, so to speak. So a little update on our splash screen there, and here we're straight into the new front screen. Really nice interface, showing you integrated analysis and design, and then the modules which are accessible as standalone versions. But also, when you look at the likes of MasterFrame, it is indicating to you that, well, actually this is the path through to integrated design for all of these different types of design: steel, concrete connections, pile caps now there, composite design, and timber. And this will also indicate to you which of these you're actually effectively licensed for. The ones that you're not licensed for will be indicated in a slightly different color there. So straight away, getting into the modules is much quicker and easier. The recent files is also more prominent there, and then the usual announcements that you saw on the previous window have been extended, so there's a much bigger space available for those there as well. So those are all the programs, really nice and easy. The other items which were previously in the menus along the top now come along to these side tab panels here. So you've got anything to do with importing from Revit, from IFC, from all these other sources is nicely configured there, and then some of the various utilities such as accessing your open libraries, your preferences in MasterSeries, title blocks are there. Your help menu now is replaced by a resource panel where you can have a quick link to the resource area for looking at the videos, and this will take you to the MasterSeries video library, which if you haven't had a look at it yet, I would highly recommend. It's an excellent resource and has got lots of really good short little videos for learning the system. So as you can see there, lots and lots of little piecemeal videos on all the different aspects and topics of MasterFrame, and that's something that we're steadily adding to and increasing on as well. A great way to learn the software. Finally, moving on to the licensing, this is where you can manage your licensing. So you've got the usual thing like your license number, things like that. And in fact, here I'm using a dongle actually, but I do want to talk about the facility to actually use a different type of licensing system, and that's the MasterSeries soft lock. We did quite a bit of work this year on if you like, giving people the option to move beyond dongles to a software-based licensing system, which presents lots of really interesting benefits. And I'm just going to actually switch across to a soft lock license, which I have available in my system here now. And it's a soft lock which is located on one of our servers here, and we've got that. And we just need to restart MasterSeries for that to take effect. And I should have the facility now to log on to this license, telling me what's available, and I'm now utilizing the soft lock licensing as it tells me here. The soft lock licensing is, if you like, quite like a network license, a network dongle license that we had previously, in that it gives lots of people across a network a shared license that can sit on a single machine or a single server to access. So even you can replace a standalone dongle with a soft lock license. There is an upgrade path to obtaining a soft lock license, which does incur a cost in some instances, or in many instances, but it has lots and lots of advantages. You've got the facility to obviously share your license more easily among a group of people. So if you have a standalone dongle with 3 or 4 different modules on it, instantly on the soft lock licensing system, you might have the facility for those 2 or 3 modules then to be used by 2 or 3 separate people, depending on the configuration of the modules. You've also then got some really clever usage information which you don't get in standalone dongles. So I can see here all the people, all the components that are available to me on my license, and who's logged into them. So which is straight away very useful to know that if you can't get into a module, you can see straight away who actually is using that module, and you can give them a nudge to potentially release it for you if they're not actually using it. So that's quite useful. You've also got the really clever facility for checking out a license, which is really important because now the dongle isn't a physical object, or the license isn't a physical object on a dongle. It's a license which sits on a server or on a PC. And if you want that license then to be portable, so you might be going off grid for a few days, taking a bit of work with you on holiday where you're totally not connected to the office, you can check out a license. Checking out a license is really useful to borrow a license from the license pool on the license server, when you can basically go in and select the modules that you think you're going to need and how long you're going to need them for, and have those available to your local machine whilst you're disconnected from the network. And that's really only recommended when you are going to be completely disconnected. If you've got a VPN connection to your software or to your server from a home location or something like that, then we recommend you stick with that. You still can continue to utilize and log on to the license via a remote connected location. However, if you're completely disconnected, this is the way to go. Excellent. So let's get stuck into the actual programs themselves and have a look at what's going on. I'm just going to use my recent files here. Well, in fact, actually, let's have a look at the new file selector. And in my file selector here, it's much more streamlined. One of the nice new facilities in it is the preview facility, whereby you get a proper preview of your graphic, and that works across the board for all of the different modules, whether it's connections through to MasterFrame through to the PalCap design. They all give you a much more representative preview of what you were last working on, saved with the file. And so yeah, that's where I want to be. In fact, I'm just going to pop back up to that level and just open up this file. Okay, so I've got my new connection open here, and straight away I'm looking at one of my new type of bracing connections. How did I get this? Well, same way you get any other type of connection. You've now got in the new connection selector interface an additional tab for bracing connections, and here are the four types: vertical brace to column, vertical brace to beam, which we'll look at in a moment, vertical brace to the base plate, and a horizontal brace into a beam as well. So looking at the brace that we have, let's just have a look and see how it's all configured. Although we have got this one connection of our connection type, which is a vertical brace to a major column. So the column is the major component. The configuration of the beams and the braces are entirely flexible within this one type of connection. This connection also, and all the bracing type of connections, is worthwhile saying, can also be integrated with your MasterFrame model, just like your other types of connection design. You just need to select the right type of connector, similar to other types of integrated and linked connections, to simply pick up on the members and have everything linked through from your MasterFrame model. However, your MasterFrame model will come through, but there will still be some work with regards to how you want to set out your bracing and things like that. So let's have a look and see what's going on here. The first thing is obviously you've got general grades. The properties of the columns are here. And then we've got a left arrangement, and then down here we've got a right arrangement. The left arrangement basically allows us to control what happens on the left of the beam. And you've got options to say that it's a gusset only, or perhaps nothing at all, or it has a beam. So we've said has beam, left has beam. Excellent. Left beam properties, because we have a left beam, are all fairly clear. And just while we're looking at these properties, let's have a look. If I click on the major column, I'm on the major column. If I click on the major on the left-hand beam, I'm in the left-hand beam. And so a lot of these properties we can click on a brace, and it navigates to the brace. It makes finding the associated editing of the component much easier. So that was the beam we were on. That's just the information of the beam that's on the left. And then we've got the left gusset plates. And because we have on the left arrangement, I should have said that not only would you say has beam, but we've also said that we've got top and bottom braces, so which is why we've got the braces in these slots. So on the left gussets, we have the top gusset and the bottom gusset because of the presence of those braces. Let's have a look at a gusset plate. This gusset is set to something called auto size, which is a really useful feature to configure automatically the size of the gusset plate in accordance with the angle of the brace, where it's connected to the setting out of the brace, and also the bolting arrangement and the default edge distances that you've got set up. So what's going on here? So we've said that the gusset is connected with the beam and the column, and we in this instance say that the clearance between the connection and the end of the brace is a 25mm. If I were to increase that to 50mm, we can see that reconfiguring itself. We've also said that the bolt edge distance between the edge of the gusset plate and the brace itself is got to be 60mm. So that in itself determines the size of the plate. So we've got the minimum end clearance in addition to the distance that we're specifying from here to here. That gives us a scope or a range that the brace has to, or the gusset plate has to satisfy. We've also said we want to chamfer the gusset plate, which is usually a nice thing to do. We don't chamfer it, we just simply get a square gusset plate, and that 60mm dimension is more at a bit of an angle. So the chamfer always goes perpendicular to the brace and can be controlled in terms of its projection as well beyond the brace by modifying those dimensions there. The brace itself, if you want to, you can say that it's not auto-sized, and the sizes that were calculated previously with the program are pulled in here. And in this case you can see the most generic way in which the gusset can be specified: a height and a width, and then you've got four regions of chamfers: the top left, bottom right, bottom left. And in this instance we've only got a chamfer on the top left, so we can see the 107 roughly rounded chamfer. in that location that was calculated, obviously in this instance, based on the width of the actual angle connection coming in here. So we'll try not to get too bogged down in many of the details here, but just to say, if you just say wanted, let's say like a snip and the inside, we could say that okay, we've got 10 and 10 there on the bottom right, and you can just about see a little snip there of if you wanted to have that not welded all the way through like that, and that would affect the length of the welds and so on in those locations. I'm just going to turn that back on to the auto size. So it's only when you've got the auto size off do you have a bit more flexibility, if you like, in specifying a more unusually shaped gusset. So the left brace itself, this is quite important. So let's have a look at the top left brace. Obviously the brace itself has a section size. In this instance we've got a 2-number 120 by 120 L shaped, so there's one of these either side of the gusset plate on a back-to-back L section. The angle is 45 degrees, great. The axial force is -100, which tells us down here that the positive is tension, so this actually produces a tension. The brace setting out is a really important area as well, because this is where we get to determine, because obviously in an idealized analytical world everything connects on center lines, but then your bracing obviously quite often will be have some eccentricities and offsets to facilitate the arrangement of the connection. There's various things you can do here. At the minute the default is that it's collected on member center lines, but we can say that it's connected on a flange center, and the actual line comes into this location here now. So that becomes the new setting out point of that, and you can see that immediately then has changed the shape of the gusset automatically, because remember the gusset is set to auto size. Another very important thing then is the offsets of the gusset. So we can say here, for instance, that we've got a horizontal offset maybe of -100, and that pulls the gusset forwards or backwards, and you can also have, let's say, a positive one there. Oh, that's obviously not what I wanted. Cancel that. Let's just set that back to 0. Yeah, something slightly amiss there with that. Yeah, let's just move on. So these are in millimeters. That all looks okay. And we're just going to put that back to 0 as well. I mean, what I was expecting there was that to move vertically by 100 as the setting out point, and for the brace to be automatically configured for that. We'll have a look at that. Here we have the bolt gusset distance, which is the distance between the edge of the gusset plate and that. Now that's more relevant if you're not set on auto size gusset, because that's actually being controlled by the auto sizing of the gusset. And then we've got the bolt geometry. You've got 2 rows of bolts at a spacing of 60, but only 1 column. We could of course go for 2 columns. In this case that actually wouldn't make much sense, so we'll just stick that back down to 1 column, and the spacing then in those directions doesn't make a pile of sense either, because you've only got 1 column now. So you've got then the edge distance. Like I say there, if you click on those dimensions, that takes you straight to the bolt spacing, the bolt edge distance, so it's all nice. And you've also got the option for staggered bolts there as well. Having a look down here actually at this brace, well, let's click on the gusset first of all. This gusset is actually set to be connected to the beam only, because the brace itself, if we click on the brace, has a setting out where it's -200 in the horizontal direction. So because it's starting to get a bit remote from the column, we think in this instance we can get away with the gusset plate only being connected to just the beam and not the column. And all the appropriate eccentricities and the additional shear forces and bending moments that get created from that are calculated and advised in the output here. And we'll talk a bit more about that in a moment or two. But just to say that in this instance we're more like a knuckle brace, as we call it. Again, the brace is auto sized. We've said that it's connected to the beam only. If I want to configure that a little bit more, I can of course turn the auto sizing off and then start to begin to experiment with the chamfering. So I could have this, for instance, coming down here and up and out by modifying the chamfers on each of the 4 corners. Let's just set that back to auto size. It might be interesting here if I were to come to this and say, let's say actually we want to set it back to beam and column, so we can see that. And back to the brace itself, I'm going to change the setting out such that it is back to the center line, and the vertical offset I'm going to say is -100 in this instance, and maybe just push that a little bit more so I can have a little bit more of a clearance from the beam. And now we're in a position whereby for the gusset we might be better to say that it's connected to the column only. So you can do that equally as well. Now on the right hand side we've got has a gusset only, so it doesn't have a beam, it has a gusset only, and in this instance we've got a slot for 3 braces, top, middle and a bottom. In this instance on the right arrangement we've said we have a top brace, a bottom brace, but no middle brace. You want a middle brace? No problem, you got a middle brace. We'll just turn that off again. So likewise the right gusset in this instance auto sized again, and the right braces, we've got a top right brace and a right top brace and a right bottom brace. In this instance these are flats. Coming back to this brace, actually a couple of interesting things. This is an angle, this is a flat, this is a CHS. We can also have channel section braces. We can also have hollow section, or sorry, square rectangular hollow section braces. In the cases of all types of hollow sections, obviously then the type of connection between the gusset and the brace differs. You obviously are looking at different connector types. So clicking on here on the connector plate itself, we can see that in this instance we've set to a T plate, but you can also have an L plate or an embedded plate. So the T plate basically is an end plate welded to the section, and then centered on that we have another plate coming out from it, forming a T, and from which all the design of the welds and everything are calculated. If you go for an L-shaped section, you got to specify the size of the angle L that's being provided here instead of a T. However, straight away we're in difficulty because there is, in this instance, in this brace, we've got, I suppose, a reasonable axial force, which is a tension force of 75, and that produces an eccentricity, creating a moment on the angle of the leg. So whatever the eccentricity is between the center of the section and the center of the leg of the angle, that produces a moment, and that moment is what's causing this unity ratio here. If we were to scroll down, we'll see that in a bit more detail as well. So the left bottom, we can see that applied moment and moment of resistance being calculated, and quite disparity between the two. In addition then, we've also got an embedded plate, which is a simple plate recessed into the section by an embedment length, or embedment depth as we call it, and obviously the welds and such of that is designed, and you've also got a little bit of a sealing weld here as well if you want that. Okay, so lots of different types of configurations and options there, and everything is designed as you would expect it. You've got all the design of the gusset plate, both the block shear, here we're dealing actually with the overall design of the gusset plate, the welds. So actually this is the right one. Let's have a look at the top left gusset plate. So we calculate from this the total forces coming onto the gusset plate. In this case there's only one brace, but and on the right hand side all the forces of all the braces are summed up, and the total design of the welds are carried out, and then the actual brace itself and all the components of that are handled in this category. So you've got the bearing of the bolts on the brace itself, the bearing of the bolts on the gusset plate calculated, the bolt shear itself, the actual gusset plate connection. In this case we've got a compression, so the full compression length and effective compression width are all calculated and checked. So things like block shear with edge tear out, everything is covered. Um, I did mention earlier about the additional forces that get generated from braces. The SCI publication talks about this here. There's a bit more guidance in SCI AD 306, 307 that talks about how these braces themselves and the vertical and horizontal components of force that they come in with the axial force produce effective additional forces in potentially the beam connection and maybe also the column. So we're advising you here what the additional forces are that you may need to consider as an additional force in your design of the element itself. The additional shear force that gets generated, we can do something with that with regards to the connection, and we'll talk about that in just a moment. So everything there is to do with the design of the braces and their gusset plates, but not the actual simple connection at the end of the beam. That's still handled by the simple connection. Now, I'd mentioned there, here we have a simple connection which actually has the same column and beam configuration as one of my second brace connection there. And we have a nice facility whereby you can say that you want to link a simple connection to a brace connection to pick up the additional generated shear forces. So we're saying, yeah, it's linked, and in the case of the flange connection, I'm picking up additional forces from this bracing connection design. In the case of an integrated design, you don't actually have to make that selection because it knows the actual reference point in the frame that the connections are linked to, and it automatically picks up the associated linked connection. So if you've got a linked simple connection and a linked brace coming into the same location, and you say you want to pick up the additional forces, because the additional forces themselves are obviously heavily dependent on the setting out of the braces and the geometry that gets produced from those. So it's the brace design does have to be set up for these forces to actually be calculated and carried through. But you've got here an additional brace shear of 123. If I were to go back to the other brace, we would see that value being calculated from, I think there was effectively a compression from the top and a tension from the bottom of two amounts which whose vertical components summed to this value, and that is now carried through to the simple connection. Moving on to a different type of connection here, we've got the major beam with a column. All the options in the setup of the gusset plates and braces are quite similar, except we've got a major beam going through on which the gusset plates are primarily attached, and the option of a column above and or below. So we have a column below but not above, just like in the other connection we could have a beam to the left and or right. So there's quite a bit of similarity obviously between the connections. They're just a different orientation and configuration. When you're doing an integrated connection design, you obviously need to be selecting a major beam or major column type of connection to link to the appropriate part of your frame, so it gets this type of configuration right for what you actually have in the physical world. Similarly as well, we've got a column here with braces coming into it. One of the things I didn't actually mention in the other types of connections, and this is pretty important I guess, is the braces here are coming into the flange of the section. However, it is possible to say you want to brace on the minor axis, so all the braces come into the minor axis of the column. So when we think about the simple connection I had then set up subsequent to that, the simple connection itself deals with all the beams coming into both the major axis and the minor axis, all on the one simple connection. However, the brace connections are handled, you'd have to set that up as two separate connections. But in the actual simple connection, there was an option to link to a brace to major axis joint and a brace to minor axis joint. So you might have one of each of these if you had the unusual scenario of braces coming into both axes of a member. Then both sets of connections can be linked to your single simple connection to pick up the forces in each of the two separate major and minor axes. I hope that's clear. So let's come along to this is a column base plate, and we can say that again we want it to be on a major axis or a minor axis. So this is our major axis. We can obviously extend the width of the plate, so the gusset plates are auto-sized in a more regular rectangular shape. But the choice is yours. The actual components of design, everything that's done are as per the recommendations of the Green Book and as per the things we've looked at previously. Here we've got a third type of bracing connection, and this is more akin to horizontal bracing, or it could be close to horizontal bracing coming into, say, the minor axis of a rafter in a portal frame. So what we're looking at here is a beam on plan. This is the web of the beam. The gusset plate connects to the web of the beam I section, and everything is designed in the similar sorts of ways. We have a variation of this is back to vertical bracing. In this instance, we're actually looking again at a major beam brace connection. And in this instance, the major beam is set up to say just have braces on one side, not both sides. So you can see, for instance, the bottom arrangement, and there's no top arrangement. This actually, I'm presenting this because this is a special case of where your major beam is an angle or a double angle. You can actually say that it's not welded but bolted, and in this instance your gusset plate is then bolted to this, and quite interesting design occurs. All the forces and all the braces are summed up, and the axial force, shear force, moment produced by them gets resolved into the bolt group, and then the bolt forces are generated and checked in the appropriate manner. So that's quite a useful little connection to have at your disposal as well. Okay, so that is the summary of the bracing type connections. I've spent quite a bit of time on those, so I'm going to have to pick up the pace here a little bit. We've got some new features in our moment connection for beam to column, i.e. in this instance the forces in the beam produce very little moment but predominantly an axial load. That presented a problem previously because the whole design methodology of the Green Book connections works on the principle that you've got a moment couple that produces a compression on one side of the joint and tension on the other, and that derives the derivation of the moment capacity of the joint. Not so then, that kind of breaks down a little bit whenever you predominantly have not a moment couple but both compression on both sides of the joint and tension on both sides, or tension on both sides of the joint. So here we've got an axial force which is a compression causing compression on the top and the bottom. So the software, you don't have to worry about choosing this scenario. The software will recognize and calculate the appropriate scenario of having compression on the top and or the bottom. Likewise, if I were to change the sign of this here, we then are looking at tension, whereby we've got an entire tension zone all the way through the joint. A little bit more complicated in this instance because of some modifications that are required for the bolt row capacities, which are primarily set up previously for a distribution of top down, whereby you've got tension on the top dissipating to quite low value of tension on the bottom. So that required quite a bit of significant work to actually make that work in a sensible engineering way. So the joint is in full tension here, and the capacities are readjusted and redistributed in a very appropriate way, without getting into too much more on that at this moment in time. Now that has facilitated another fifth new type of connection for MasterSeries 2019, whereby we've got almost the same as a beam to column connection but rotated through 90 degrees. So this is where you've got a beam and a column, and this is a moment connection. So in this instance, again, the column forces are quite a large axial force on the column, and that has transposed through to quite a bit of compression on the beam that's being checked here. So the beam web buckling both on the right and on the left is in problems. So we can look at providing some main stiffeners on the left and the right. So we can just say we want a 10mm stiffener on the right and a 10mm stiffener on the left, and those problems are disappearing, but then we've still got some beam web shear problems, so you probably need a diagonal stiffener across that there to try and satisfy that. So maybe you can go for a 10 mil. In this instance, you probably wouldn't go for a Morris stiffener. You'd probably just go for a full diagonal stiffener to satisfy that. And it's just giving me some warning there with regards to bolt accessibility. So that might need to be thought about a little bit, or pull the bolts in a little bit to satisfy and get yourself around that, as is noted in the dimensional checks here. So this is very similar to a beam to column moment connection, but transposed through 90 degrees. And in fact, it goes beyond this simple configuration here. You can extend the end plates out, put in gusset plates, even have a haunch, all of which are because it's a sister connection of the beam to column moment connection. So those are the new types of connections. Again, you've got the graphical interaction, including clicking on things like wells to get straight to the wells, clicking on bolt dimensions to get straight to the bolts, top bolt, bottom bolt group. All very, very useful. Okay, let's move on from connections now and have a look at some of the new features in the MasterFrame Pro. So let's just come out of here. So I've got a little file here. I'm just going to go straight to it from the recent files, and okay. So simple multi-story frame here, gravity area loading turned on. Let's just get rid of that. And what we're looking at now is the new facilities for line load, patch load, and point loads now being separated from patch loads, whereas previously they were sort of a pseudo patch load. So let's get into the line loads. Now the first thing to say is the interface is obviously very different. You will have your old files upgraded to the new style of line loads and patch loads. When you open the file up in the MasterSeries 2019, it will make a backup copy of your previous version and notify you of that, and you can then access that. So you can just satisfy yourself that everything has migrated across in appropriate fashion. So line loads, patch loads, and point loads. We're looking at line loads, and they are split up into nice convenient sets. So I've just added a new line load set. And what does that mean? It means that everything in this set of line loads obviously will have a set of load values. So I'm going to say I've got 5 kilonewtons in the dead, maybe 6 kilonewtons in the live, and you can add more items or remove items. So it very much works like a collection as opposed to the 5 fixed groups that you had previously. So you can add up to your, well, as many different groups as you want, but effectively there are 11 different individual load group letters that you have access to separate out the loads into different load groups. So those are the values of the load specified. We'll come to this varying aspect in just a moment or two. Now, the placement method. What I want to say first of all is that we have a very flexible placement method now where you can just draw the loads. However, you still have something that's more akin to what you've had previously, and that's on member or offset from member. So on member is whereby, let me just come to a level, planet level 1, and rotate it around a bit, whereby we can simply go into select mode, select the members that we want to apply the load to, and the loads are on the member. Simple and straightforward. And this is nothing more than a UDL, the same way, and you would effectively have got the same thing in the old style of line loading, because it was entirely based on member selection with offsets. If you didn't specify an offset, then it was by default on the full member, and that is equivalent to that. Equivalent to the old method is also then the member offsets, whereby you've got the facility to say that I've got a start and end distance and a start and end offset. Now I've selected these 4 members, and all of them have start and end distances of 1 to 3 and start and end offsets of 1 and 4. You'll be familiar with that because again it works in a similar way to the current MasterSeries 2018 methods. Your files that are migrated forward will migrate to these settings to maintain that compatibility. However, for producing new works, we would highly recommend that when the loads aren't on members, that you use the draw facilities. And in fact, when you change to a draw mode, it does convert the loads to what we call the free drawing mode. And I am just going to reset this here by selecting those items, and I'm just going to delete them because we're just going to go back here and now change this here such that we are simply going to draw these loads. So the draw mode effectively requires a level, and at the minute we're on level at a y coordinate of 3.19, so that's the ground floor. Let's select that. We can say then we've got a level offset to push the loads above the level. So when you're drawing the loads in, you got to associate them with a level, which means that it's a really good idea to generate levels. And it's always been a good idea to generate levels, but now even more so. You need at least one level to locate these types of loadings, but it's a really good idea to have a proper level generated at each of your levels, and that's done through the add edit levels from the create menu. Let's get a few of these loads in. Let's draw them in, and as soon as we click on draw, we're in a more of a snapping arrangement, so I can click at any point and start drawing in a polyline of loads. I drew those in quite quickly there, but those of you who are familiar with MasterSeries will know that you've got hover points to create tracking points. You can then start to type distances in from those points. So all of the facilities that you have when generating members are available to you here when you're drawing loads. So all of the things like if I want to create this load at 1,0,1 away, so that's a reference to say that that is 1 meter away in the X and in the Z, then that load gets generated. I exit draw mode by clicking on the button or pressing the escape key. I find the escape key a little bit more convenient. Now, these individual loads can be selected, deleted, manipulated, shifted, rotated, copied using the editing tools. What's more, they can be individually manipulated using these handle points. So I can click on the ends or click on a midpoint to move things around, again in a controlled fashion. I want to move that across by 1 meter. I type in the 1 meter on the track line to get that shifted in the appropriate direction. If I want to then do that on several of them at the same time to move them all, I can grab that whole set. Holding down the control key as well exhibits the standard Windows behavior in that it multi-selects. So without the control key, you're selecting an item. With the control key, you're selecting multiple items. Or you can obviously window select to select lots of items at the same time. So now that I've selected a few items here, I can say I want to move them, say from this point across to this point, or I can say I want to rotate them by say 15 degrees, maybe about this point, or I want to copy them from this point across to this point. So you can see the flexibility and how quick it is to generate these loads and move them and copy them around the place. Okay, so I'm going to grab this set here, including this one, and just delete those. And maybe take these ones and just move them into a slightly more sensible place. Not really, because I want them to be inside the structure. That's fine. Obviously, it doesn't make a lot of practical engineering sense what I'm doing here, but that's not really important. So scales are down here. Now this represents one set of loads in that they all have the same values and the same placement method. If I want then to add another set, I can simply add another set or have this set copied. Let's just go back out to the full frame view here. Adding in another set means that again I maybe select a level. I might go to another level, and let's just go to that level, which I believe is level 2. Yeah, and I can start again specify the loads and start drawing those in. Now, if you have a situation whereby you've got multiple sets, you can move between them using this facility. The reason why this one is coming into view now is because the selected one always is visible. Otherwise, because it's outside the view, you don't see it. But I can navigate to these sets by clicking on them, and you can see it moves between the sets. Or I can select multiple sets and actually change their values altogether in terms of their load values. So I have the facility of multi-editing numerous sets to set their values to be the same, say, load value. If I wanted this load set here to be present also in another level, I have a couple of different options. I can copy the load set and then change its level value to a different level. And that might be useful if I wanted then to manipulate that load and make it different. However, if I know that this load repeats at other levels and it's identical, and all the loads in this set repeat at other levels and they're identical, I have this lovely facility of, say, repeat level, whereby I can say, yeah, the parent level is the ground floor, but actually I also would like this level to repeat at the mezzanine level. And in fact, I can go more. I can say add another item, and I also want it to repeat at the first floor level. So I can very easily now have this one load repeated at multiple levels, with the parent load being manipulated and controlled from the first floor. So if I move the loads or do anything from the loads on the parent level, they will automatically be updated at all the associated levels. I'm just going to turn that repeat off. So some really, really useful facilities there with regards to those loads. Patch loads as well. Oh, I should have said we also have varying loads, which is really quite simple. You say you've got a varying load and you specify a start and end varying ratio, which varies the entire loads and looks at the loads. If you've got multiple loads, it'll always look at the loads as a polyline, starting at the start of a polyline and ending at the end of the polyline. So if some loads are varying, some aren't, then you're better to split them into different sets. This will vary all the loads in this set. Patch loads. Let's get back to my planet level 1 and let's add in a patch load. By default, it goes to the view that I'm in with regard to the level. Similar sort of thing. You've got draw mode or reference from member mode in this instance, which is similar to what we had before. But now we've got, we're going to place these things in draw mode. Let's get some values of load in here. And we're going to simply start drawing these in. Now there's a couple of different methods. There's draw polygons, draw a rectangle, or pick panels. Draw a rectangle is simply just draw a simple rectangle. Pick panel is where you want to put a patch load in an entire panel. You can pick the panels, albeit the area loading facilities are better for doing that. So I just want to draw in a polygon, and let's see if I can start in the middle of that member, come down to here, come up to the middle, over, down, across, and back to the beginning. And the patch loads themselves have tracking points, so you can hover over a point of a patch load, and that will act as a temporary tracking point and things like that. So they behave in a very similar drawing fashion to real members. So this is my patch load. Again, I can manipulate that. Let's just escape to exit draw mode. Clicking on it, I've got the same handles I had in the live load. I can do all the same facilities. There's a little extra facility here called cleanup, which means if I draw extra lines that effectively don't form a patch, then the cleanup will simply tidy up those and get rid of those. Let's just move that back down this direction by 1 meter. And similarly, repeat level, things like that are available a very similar way to the line load. The varying load now. Let's look at the varying load. I've got 3 varying ratios. Let's specify one as being 0.1 and leave the other 2 at 1. And now it's telling us we've got to pick 3 points. If we look at the information, pick 3 points in the patch load that the 3 varying ratios refer to. So I need to locate these ratios to 3 points on the patch load. Let's pick them. So I want the the first ratio to be here, the second ratio to be here, and the third ratio to be here. And that varies my patch load appropriately, so that I now have a varying plane. Again, if you've got multiple patches in the one set, that plane will actually apply to all the patches in the set from those 3 points. So if there's only the one load you want to vary, then you're better off keeping it in a set of its own. Point loads, because we're running out of time, we're going to expedite this. A very similar type of thing. Apply a point load. Either it's on a member or offset from a member, or you want to draw it. Let's draw it with a load, something a bit bigger, of 50 dead. Yeah, it's on this level, and we simply just want to draw it in. So you're just picking points now in this instance, either on members or off members. And the distribution of the load back to the members again works in a similar fashion to what we had previously, in that it interacts with the underlying gravity area loading to cast itself back onto the members accordance with the direction of span of the underlying panels. In a similar way, if you apply patcher point loads outside of area loaded panels, then you're going to get the same types of error messages telling you that loads are outside regions and need to be addressed. So that same protection is there that you had previously. So if you want to delete a whole set, I think we've saw that already, you can do that, or select multiple sets to edit their values all at the same time. You can click the control key, select multiple sets either on the list or graphically. So it's a really good and powerful editing interface to facilitate those new things. What we did find actually was when we started to look at continuing to build up these loads in real world models, if we go back to the line loads and let's go back out to the full frame, obviously when you're looking at a full frame, the green actually is the current load, the cyan is the preview of what you're about to pick. Where you've got lots and lots of these loads and they're all drawn together, things can become a bit crowded. So this draw only the selected load is quite useful, to draw only the current load that you're editing, but the other loads are still selectable, and you can see their little placement lines there. It just helps to reduce the noise a bit, as does the reduction of scale help to reduce the noise a bit as well if you have lots and lots of loads going on at the same time. So those are the placement of our line and patch loads, which just really gives me a few minutes to finish up by looking at the final feature that we're focusing on today, and that's the integration of pile caps. Turning on the drawing of the pile caps, which is now, this is the drawing of the foundations, not just pad foundations. So some points have pad foundations, other points have a pile cap design associated with them. Let's get ourselves into the design then for the pile caps. And because we've fired on some loads, we've got to do some analysis. Okay, so I've got a number of pile caps here already, and as you can see, you've got 10 pile caps. The integrated design interface is very similar to what we get from all the other different integrated design materials, whether it's steel, timber, composite. You've got design briefs, which are associated in this instance with support conditions, and each of those briefs then can be individually manipulated. So I've added briefs here already. I can of course take a brief and copy that brief, so I can copy that brief and maybe add it to another location, and I can offset the center of the column. So say I want to offset in the Y by 200 millimeters. We can see that both occurring here and here. If I just turn off the drawing of the guidelines for a second or two, you can see actually there's a little beta symbol in the column here, which is really useful in terms of locating the beta of the column to the beta of the pile cap. That might not be such a big deal when you're looking at a triangular pile cap because it's got unique geometry in a particular direction, but in a square based pile cap you really do need to know, obviously, what direction the column is in relation to the pile cap, so you orientate the pile and place the reinforcement appropriately. In this case, actually, I've only got vertical axial load and everything's fairly symmetrical anyway. However, if there were moment coming through and things like that, then you would have asymmetry in the design of your pile cap, and it would be important for that to be recognized in that scenario. So in relation to the orientation of the pile cap, you have control over that. You can say that the pile cap can be transposed or rotated about its principal axis of the column. So it does follow the axis of the column and then can be adjusted by additional amounts to have that pile orientated in whatever fashion you want. All the load cases from the analysis are taken through and the critical case is selected. You can scan all the cases to determine which one of them is the most critical. We're back to load case 1 in this instance. So it's a really, really useful and powerful facility now to have linking through. Okay. So those are just some of the features you've got to look forward to in MasterSeries 2019. We're continuing to work hard for you in the other features that you've got to look forward to later on in the year, such as the slab design, and we really look forward to presenting those to you in the not too distant future. Remember, if you're interested in signing up for the next webinar, keep an eye on that on the front page of the MasterSeries web or MasterSeries program or on the MasterSeries website. And if there's anything in the MasterSeries that you've seen here today that you don't have and you would like to talk to us about it, we'd love to hear from you. So thank you very much, and we look forward to getting MasterSeries 2019 to you very, very soon.